All right, look at slopes of straight lines here, if you will. Okay. Let me give you a couple of tables here, for example, of points here. Let's look at x and y. Remember when we saw how to make that table, x and y? But this time, let me not start off with the equation yet. Let me go ahead and give you the the table here. Suppose when x is 0, y is, let's say, 2. When x is 1, let's say y is 4. Right? When x is 2, y is 6. When x is 3, let's say y is 8. Okay? Now, let's take a look at this example here for a second. All right? Now, notice I want you to see a little pattern between the x and the y, that is, namely. All right? Now, for every unit of increase on the x column, so from 0 to 1, there's a what? There's a 2-unit increase on the y column. So if x increases from 1 to 2, then y increases from what, 4 to 6. If x increases from 2 to 3, then y increases from 6 to 8. So again, for every unit of increase on the x column, there's an increase of 2 units on the y column. All right. Now, if I take the ratio of the, so let's look at the ratio of the increase of the y's to the x's. Well, that's not going to be hard to figure out at all, right? Because, again, for every unit of increase on the x, there's a 2-unit increase on the y, as you can see. So, therefore, the ratio of the increase of the y's to the x's will be what? 2 to 1, right? That means what? 2 over 1 here, okay? This ratio of increase of the y's to the x's is actually called the slope, all right? So this is, think of this as the slope, if you will, slope of a line. All right. Now, before we get more into slope here, let's look at this concept right here. So what this 2 over 1 is telling me is that there's a 2-unit increase so on the y's, and for every 1 unit increase on the x's. In other words, so if y is getting higher and higher, that means we're going up. Right? Remember, positive y means we're going up on the rectangular coordinate system, and positive x values means we're going to the right on the in the rectangular coordinate system. Right? Correct. So therefore, that means what? That means if we go to the right 1 time, so this means to the right. This means 1 right. Okay, and this means what? 2. We go 2 up. In other words, for every unit I go 1 to the right, I'm going to go 2 units up here. In other words, so if I start up at 0, 2, let me go and plot some of these points, but not all of it. Okay, so here's y, here's x here. So 1, 2, 3, 4, 5, 6, 7, 8. All right, 1, 2, 3, 4, 5. All right. So if I start off at 0, 2, for example, on this table here, right? So for every unit I go to the right, so it says what? For every time I go to the right, every time x increases by 1 unit here, that means I go to the right 1, then I'm going to go up what? I'm going to go up 2 units. So for every increase of 1 unit on the x column, there are 2 units of increase on the y column. So that means I'm going to go 1 to the right and what? 2 up. Right? Similarly, if I increase it to, again, if I go 1 to the right again, then what do I do again? Well, I go 2 up again. Okay? Likewise, if I go 1 to the right again, I go 2 up again. So as you can see, these 4 points right here, they do make a straight diagonal line, as you can see right here, if I connect them. Okay? So, what this ratio tells us is the slope of the line, as I mentioned, but what the slope means is the slope measures the slantness of the line. So slope measures the slantness of a line. So this tells me, the slope tells me how slanted this line is. For example, what if well, for every unit increase of x, then 1 goes down 1 unit. Then that means what? If I go 1 right, 1 down, now the line changes, if you will, for example, right? So again, the slope measures how slanted a line is. Okay, let's look at more details in terms of that. And let me give you an alternative definition of slope. Again, that means what? From this table here, for every increase of 1 unit, y increases what? 2 units. For every increase of 1 unit from the x column, y goes up by 2 units on the y column, that is. Okay. So let me go and clear out this screen here. All right. Let's consider a general graph right here. All right. Let's say I have 2 points right here. Okay. Let me put 2 points in the first quadrant for simplicity's sake. All right. And let's say this point has coordinates x1 and y1. All right. Let me put another point up here in the first quadrant. Let's say this point has coordinates x2 and y2. All right. Let me go ahead. So this point has some x coordinate, some y coordinate. This point has what? A different x coordinate and a different y coordinate than these two. All right. So if I connect them to get my line, let's say my line goes through them. Okay. So sorry, it's supposed to go through it. My apologies there. Okay. Let's say my diagonal line goes through these 2 points, x1, y1. Here, x2, y2. All right. So let's look at then the increase. Let's look at the ratio of the increase of the y's to the x's. All right. Let's look at the y's first. All right. How do I calculate this increase right here on the y's? So here's the first y right here. So here's the first y. All right. It goes all the way up to here. That's the second y. So this is y1 here. This is y2 right here. All right. So how do you find out how long this length is right here? So notice, what is this distance right here? Notice, what is the increase from the y's? Well, to find that, wouldn't I take the difference of the bigger y coordinate minus the smaller y coordinate in this case? All right. In other words, this distance here is going to be what? Y2 minus y1. Okay, it's a little abstract, so bear with me here. All right. So that's the increase on the y's. All right. This is the amount of increase in the y's. Just take the difference of y2 and y1. And similarly, to get the horizontal increase of the x's, how do I go from, so how far do I move to go from x1 to x2? So here's x1 here on the x, go all the way over to x2. How far do I move? Well, then I just take the difference again of x2 and x1. So this will be x2 minus x1. Okay, so that's x2 minus x1. All right, so now we know the ratio now. So the ratio of increase of the y's to the x's in this example will be what? Well, will be, so the increase of the y's is going to be what? Y2 minus y1, so it's going to be y2 minus y1 over, what's the increase of the x's? Well, from here to here. So what is the amount of increase from here to here? Well, it's going to be x2 minus x1. All right? And that's precisely the slope formula that we're going to use to calculate the slope of 2 points. So notice, if I give you 2 points and the line goes through these 2 points, then how do you find the slope of this line? How do you find out how slanted is this line? Well, you're going to use this formula here. Okay, y2 minus y1 over x2 minus x1. Now, what is y2 minus y1? Well, again, that's the change in the y coordinates of the first point to the second point. In other words, this is the vertical change. So think of y2 minus y1 as the vertical change. Now, you may have seen this term, vertical change, as the rise. Okay. Think of the change in the horizontal distance of the 2 points from here to here as the run, or the horizontal change. So this is the horizontal change. So the vertical change is what? Y2 minus y1. The horizontal change is x2 minus x1. And again, think of this as the run. That's why we often hear the term slope equals what? Rise over run. So in other words, we often see that the formula slope equals rise over run. Again, that means what? Vertical change from one point to the next point. Run is what? The horizontal change from one point to the next point. So this is the rise, this is the run. Okay? So slope is rise over run. Now, so and the formula is what? Y2 minus Y1 on top then, X2 minus X1 on the bottom then. So think of slope as a fraction because it's a ratio of the increase of the y's to the x's, all right? So slope is rise over run. So again, we use this formula for slope then. Now, the letter we use for slope happens to be m. That's right. So m will be equal to y2 minus y1, all right, over x2 minus x1. Okay, so this is the slope formula we'll use to calculate the slope of the line going through 2 points. Okay, let's use this formula and calculate a few. Let's do a few slope calculations here from the homework. All right, let me clear out the screen. Okay, suppose I want you to find the slope here of these 2 points. Let's I give you 2 points here. Let's make the first point 4, negative 3. So 4, negative 3 is the first point. Let's say the second point is going to be negative 2, negative 5. All right. So let's find the slope of the line that goes through these 2 points. I'll just say find slope, but that means what again? Find the slope of the line. Suppose I have a line that a diagonal line, straight line that passes through these 2 points. What is the slope of that line? All right. So again, let's use the formula. So m is equal to what? Y2 minus y1 over x2 minus x1. All right. Again, rise over run. Vertical change over horizontal change. All right. Now, let's label our points a little bit so we know what numbers to plug in. So this is x1, this is y1, this is x2, this is y2. All right. So let's plug them in then. So that's going to be what? Y2 is what? Negative 5. So negative 5 minus y1. Y1 is what? Negative 3. So minus negative 3. Make sure you plug in using parentheses for the negative numbers, especially the y1 in this case. All right. So again, y2 minus y1 over x2, negative 2, x2 minus x1, which is what? Positive 4. So minus 4. All right. Excuse me. So let's go and perform this calculation. That's basically what? That's basically negative 5 plus 3, basically, right? So that's going to be negative 2, all right, over negative 6. Okay, and reducing that fraction, I get positive 1/3. Okay, so the slope of the line going through these 2 points is going to be 1/3. What does that mean, though? That means what? For this particular line, all right. That means for every unit I go. This means again. This is the y, the vertical change, and it's positive 1. That means for every unit I go up, if I go 1 up, that means I have to go 3 to the what? 3 to the right, because that's the horizontal change. Again, the numerator is the vertical change, the rise. The denominator is the horizontal change, the run. So what this means, and they're both positive. That means when the y is positive, that means you go up, if you recall, in the rectangular coordinate system. If the x is positive, that means you go to the right in the rectangular coordinate system. So in this case, I'm going to go 1 up and 3 to the right. We'll talk more about this when it comes to graphing, though. Right? Don't worry about that. Right now, we're just finding the slope of the line that goes through these 2 points, and we're just applying this basic slope formula. So no big deal here. Let's try another one. Let's look at the the points of. Sorry about that. Let's look at the points. Sorry about that. Let's try this one. Let's look at the points. Negative 1, negative 1, 4, and the points 0, 0, 3, for example. Okay. Let's go ahead and find the slope of the line going to these 2 points. Okay. So again, let's write down the slope formula. So m is going to be what? Y2 minus y1 over x2 minus x1. All right. So again, this is x1, this is y1, this is x2, this is y2. Label your points. That way you know what numbers to plug in. So that's going to be y2, so 3 minus y1, 4, all over x2 minus x1. So 0 minus negative 1. Can we see that? All right. Again, y2, 3 minus y1, 4, all over x2, 0, minus x1, negative 1. So put that in parentheses. Okay? So that's going to be 3 minus 4 is negative 1 over positive 1, basically. This is 0 plus 1, right? This is essentially 0 plus 1 down here, all right? So the slope of this line will be what? Now, negative 1 over 1, yes, that's a fraction. Perhaps you think that I should leave this answer as a fraction, but when we're covering the slope, if we can simplify it into an integer, then let's do that. So negative 1 over 1 is what? Negative 1, okay? But when we're graphing, though, you do want to write the slope as what? As a fraction, because you want to write it as vertical change on top, horizontal change on the bottom. All right, so again, no big deal there, using the slope form. Let's go and do a couple of more slope calculations. Let me clear off the screen here. Let's calculate the slope for these 2 points. Let's look at the points negative 3, comma 2, all right, and the points negative 1, comma 2, all right. Let's go ahead and find the slope again. Okay, so let me find the slope again. So x1, y1, x2, y2. Okay, find the slope. Use the slope formula I gave you in the last screen. Okay, so that means m is going to be what? Well, y2 minus y1, so 2 minus 2, no big deal. x2 minus x1, so negative 1 minus negative 3. Again, negative 1 is x2 minus minus x1, that is, so negative 3. Plug in the missing parentheses for negative numbers. Okay, again, always write down the slope formula. I didn't do that here for you, but you should do that on the homework. All right, so 2 minus 2 is going to be 0. This is negative 1 plus 3, basically, so which is positive 2. So 0 over 2 is what? 0. So the slope of the line that goes through these 2 points is 0. That means the slantness, that means how slanted this line is what? 0. So what that means is this line here is not slanted at all. Let me give you a graph of these 2 points and connect them and see what the line looks like. Right? Let me plot these 2 points in the grid and connect them. Okay, let me do it right here. Okay, so here's y, and here's x. All right. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, and 3. Okay. So let's plot the first point. Let's plot the first point. Negative 3, 2. So negative 3, 2. There it is. Okay. Let's plot the second point. Negative 1, 2. Negative 1, 2. There's that. And if I connect these 2 points, you can see clearly that this line is what? A horizontal line. All right, that's a horizontal line. All right. So one can conclude that the slope of a horizontal line is what? Well, 0, because it's not slanted. So don't say no slope. Don't say there is no slope for a horizontal. There is a slope. It's 0 because the line is flat. A horizontal line is flat. It's not slanted at all. All right. So the slope is 0. All right. So all horizontal lines have a slope of 0. Keep that in mind. All right. Let's do another one. How about the points? Let's do the point 3, negative 1. Let's find the slope of this point with this point here. 3, 3, 2, for example. All right. So let's go ahead and use this again. Here's x1, here's y1, here's x2, here's y2. Let's use the slope formula again. So m is going to be what? y2 minus y1, so 2 minus negative 1, all right? y2 minus y1, over x2 minus x1, so 3 minus 3, as you can see. Not too bad. So that's going to be 2 plus 1, so that's going to be 3. Well, that's really 2 plus 1 up here, right? 3 over what? 0. And if you remember, with fractions, we cannot divide by 0. So therefore, this is undefined. You cannot have 0 in the denominator. All right? So if it's undefined, that means what? That means the line that goes through these 2 points, well, we cannot measure its slope. The slope is undefined. That means no slope, or undefined slope, if you want to call it that way. Let's plot these 2 points and see where they are at. Okay, see what kind of a line is that going to be. All right, so let's see here. 1, 2, 3, 1, 2, 2, 1, 2. Okay, so let's plot the point 3, negative 1. So here's 3, negative 1 right here. And the point 3, 2. So 3, 2. As you can see, I have a vertical line right here. All right, when I connect these 2 points, I have a vertical line. So this is a vertical line. All right, and then we can again conclude in this case that so look at the vertical as well as vertical. So there's no way I can measure how slanted this line is. A vertical line is infinitely slanted. So there's no way I can measure how slanted the line is. So that's why a vertical line has no slope. So let me say m is equal to what? Undefined, or no slope. All right, so what is the slope of a horizontal line? Well, it has a slope. In fact, it's flat, so slope is 0. But what is the slope of a vertical line? Well, we cannot measure its slantness at all because the slope is what? Undefined. Okay, it's infinitely slanted. So again, horizontal lines have slope 0. Vertical lines have undefined slope, or no slope in this case. Okay, let's look at the concept of graphing then, all right? Let's recall that equation that we saw earlier. Let me clear up the screen. Earlier, we saw this equation of a diagonal straight line, y equals mx plus b. No, that's right. And this equation here is the slope-intercept equation, of a line. Okay, so y equal to mx plus b is the slope-intercept equation of a line. So what does that mean? Well, if I give you an equation like this, then you need to be able to pick out two pieces of information immediately. All right. The first information will be the slope. Well, that's m. That's the slope. We saw that. M is what? y2 minus y1 over x2 minus x1. So m, we use m for slope. So m is the slope of the line. So be able to pick up the slope given an equation in that form. All right. B is what? It's the intercept. In particular, it's the y-intercept. Okay, it's the y-intercept. Actually, it's the y-coordinate of the y-intercept. Okay, because the complete y-intercept of this line is actually 0, b. All right, so b is actually the y-coordinate of the y-intercept. This entire ordered pair is the y-intercept. All right, so because therefore the y-intercept, x is always what? 0. Remember that. Right. So again, two pieces of information to pick out: the slope of the line and the y-intercept, given an equation like this. So if I ask you to graph an equation like this, you no longer have to make a table like you did in the previous section. You still can, but it's not necessary anymore. For example, let's go ahead and graph this line. Let's use this concept. Let's graph y equal to 2/3 x minus 1, for example. All right? All right. Now, let's pick up the slope once again. So m is going to be what? 2/3, right? That's the m. All right? Let's look at the y-intercept. Well, that's going to be, here's b. b is what? b is -1. All right, b is -1. So the y-intercept is going to be what? 0, -1. Can we see that? Again, b is what? -1 here. Think of this as 2/3 x plus -1. So b is -1 in this case. Okay? All right then. So we have our slope. We have the y-intercept. How do I go about graphing this? Well, here's how we go about graphing it. We're going to start. So you start graphing this. So again, we're not going to use the table now. You can still make a table you want where you pick x and plug it in to get y. Remember that? We did that in the last section. But we're not going to do that anymore. We're going to start off with the y-intercept. Okay, so start, in this case, we'll start at the y-intercept. Okay, so let me make a grid right here. So here's y, here's x. So 1, 2, 3, 1, 2, 3, 2, 3, 1, 2, and 3. Okay, so I'm starting off at 0, -1. So I'm starting at the y-intercept. Okay, so let's pay attention to this carefully here, right? So starting at the y-intercept, with no more table here, right? I'm not making a table anymore. All right, I still can, but we don't have to anymore. This is a faster, quicker way to graph, all right? So I'm starting off the y-intercept. Now, how do I find the next point? Well, that's where the slope comes in. Okay, so let me say find other point using slope. Okay, so find the other point using the slope. All I need is 2 points. I have the first point already, it's the y-intercept. I just need another point to make it work. So the slope we mentioned is what? Let me write it again. 2/3, right? And I mentioned that's what? That's vertical change on top over horizontal change. Okay? So the top number is the vertical number. The denominator is the what? Horizontal number. So and they're both positive in this case. All right? That means, so it's positive on the vertical number. That means what? you're going to go 2 up. If it's positive on the horizontal number, that means you're going to go 3 to the right. Okay? So what does 2 up, 3 to the right mean? Well, it means that, so we start off at the y-intercept 0, -1, there it is. From here, from this starting point, I'm going to follow this recipe, this formula, all right? And that means I'm going to go 2 up. The next point is going to be 2 up and 3 to the right from this starting point. So I'm going to go 2 up, 1, 2, 3 to the right, 1, 2, 3. Put a point, okay? That's my next point, okay? So let's go and connect them, all right? And we have our line, okay? So this is the graph of 2/3 x minus 1, if you will. Now, you may be tempted to test this a little bit. Well, let's say I try to make a table here, okay? Let me make a table. So instead of doing it this way, suppose I make a table here, all right? Well, if I make a table and I choose x to be 0, what happens? Well, if I plug in 0, then wouldn't that thing drop off? I get -1. So look, the starting point, 0, -1. There we have it from the table even, all right? Table verifies that, okay? Now, let's pick x to be what? Let's get the 3 to cancel out. Pick x to be 3. So 3 for x, all right? 3's cancel out. That's 2 minus 1, which is 1, all right? 2 minus 1 is 1. So, and look at this point here. This point here is what? 3, 1. So precisely, we get the same points using this graphing technique versus the table method, all right? But either way is fine, but I'll give you a problem later on where you cannot use the table method, all right? So we'll talk more about that in a little bit, all right? But again, get used to doing it using the slope-intercept idea here, right? That means, well, given the slope-intercept equation of a line, what do? You first figure out the slope, then you figure out the y-intercept, then you start at the y-intercept, and you find the next point using the slope. So I start at 0, -1. Then I go, what, 2 up, 3 to the right. Because the slope is 2 over 3. +2, +3. Again, the numerator is what? Is the vertical change, the rise. The denominator is what? Is the run, the horizontal change. And it's +2 on the rise. That means go 2 up. +3 on the run. That means go 3 to the right. Okay, so I want you to follow all these steps when you're graphing on the homework, all right? Let's try another one. Let me clear out the screen here. Let me clear this out if you will. Okay. All right, let's look at this one. Let's graph. Let's graph. Let's see this graph. Let's graph 3x, 3x, 3x plus 2y is equal to 4, let's say. All right. Now here's an equation that's not in slope-intercept form. In other words, this is not in the form of y equal to mx plus b. Right? Remember we saw a problem like this in the last homework as well? Well, let's go and get it in that form. And how do you get it in mx plus b form? Well, you solve for y. So let me do that. So 3x plus 2y equal to 4. Let me solve for y. Subtract 3x on both sides of the equation. All right. Make sure we're sharp on getting in mx plus b form. Later on, I'm just going to solve it in my head, if you will, right? I expect you to understand how I did it in terms of the algebra, all right? So 2y is going to be, again, write the x term first, -3x plus 4, all right? Divide both sides by 2, so divide everything by 2 here, if you will, all right? So y is going to be, what, -3 over 2, so -3 over 2x, -3 x, plus 4 over 2, +2. All right. So now we have what I want, mx plus b right here, where m is going to be what? -3 over +2. All right. And the y-intercept will be what? It will be 0, comma what? Comma 2, because b is 2. All right. So again, pick out the two pieces of information: the slope, -3 over 2, and the y-intercept, 0, 2. Notice I put the negative in the middle of the fraction here. So actually, the slope could be interpreted as what? +3 over -2. Okay, so I can say, or m to be +3 over -2, because that's still -3 over 2, right? So these two fractions are the same. But but these two things have different interpretations. But I'll do it both ways for you to show you that it's all going to line up. Okay. Now, what do I do again? I start at the y-intercept. Let me make my grid here. All right, here's the y-axis. Here's the x-axis. All right, so 1, 2, 3, 1, 2, 4, 1, 2, 3, 1, 2, 3, 4. Okay. To start off with the y-intercept, so start off at 0, 2. So I'm going to start off at 0, 2 here on the y-axis, okay? Now, let me use the first interpretation. I mentioned there are two interpretations of the slope, right? Here, the first one here, the second one here, right? Let me use the first one. So m is what? Negative 3 over 2, all right? That means what? The rise is negative 3, so it's negative now. The vertical change is negative, so that means we don't go up, we go down. This means 3 down, all right? The run, the horizontal change is still positive. So we go 2 to what? 2 to the right. Okay, so let's use this interpretation. So from this starting point here, I'm going to go what? 3 down, 1, 2, 3, and 2 to the right, 1, 2, put a point. Okay? Now, suppose I use this interpretation, positive 3 over negative 2. So again, here's a sketch of my line here. So picture this diagonal line without me actually drawing it out for you. Okay, picture that's this diagonal line. All right. Let's go back to this other interpretation. So if I choose this interpretation, the rise is now positive. So that means I'm going to go, instead of 3 down, it'll be 3 what? 3 up. But the run is what? The horizontal change is negative. So you go not 2 to the right, but 2 to the what? To the left. Okay. So in other words, if I start off at 0, 2 again, we start with the y-intercept again, right? Then let's say I go 3 up, 1, 2, 3, and what? 2 to the left, 1, 2. I will end up right here. So notice this point right here. Okay, and look at these 3 points. Don't they all line up to form a straight line? It's the straight diagonal line. Sure, they do, as you can see, right? So therefore, it doesn't matter how you interpret the slope. As long as you interpret the slope correctly, meaning that the sign has to be correct. See, the slope is negative 3/2, right? So either you take that as negative 3 over positive 2, or you take it as 3 over negative 2. You cannot take it, for example, as negative 3 here and then negative 2, because negative divided by negative is what? Positive. But what? But my slope is negative. So again, so this negative sign can either go on top or the bottom, but not in both. Okay? So, but either interpretation will yield the correct answer here. Okay? As you can see, my 3 points line up very nicely. All right? So let's go ahead and connect these 3 points here. Okay, so again, it's a little hard to do on the sketch pad, but hopefully you can see the 3 points lining up, and we get that diagonal line. So sorry about that, but the 3 points are here, and down here. Okay. So, but again, all you need is 2 points to get the line. But I'm just showing you that the interpretation of the slope, as if you interpret it correctly, the answer still comes out. Okay. So the key is what? First, be able to get these equations in what mx plus b form here. Okay. Let's try another one. Let's look at this problem. All right. Let's go ahead and graph this line. Let's graph the line 5x minus 4y is equal to 4, for example. All right. Let's go and graph that one. Okay then. So let's go ahead and graph this line right here. First, again, I need to get it in what? mx plus b form. So let's do that. So let's go ahead and solve for y, that means, right? So 5x minus 4y equal to 4. We're going to get y by itself. Subtract 5x on both sides. Again, we've got to be sharp on this algebra of getting y by itself. So negative 4y equal to negative 5x plus 4. Make sure we see that. Write the x term first because we want an mx plus b form. Divide both sides by negative 4. So divide everything by negative 4 here. Okay, takes care of that. So y is going to be what? Negative divided by negative is what? Positive. So positive 5/4 x. 4 divided by negative 4 minus 1. Okay, so this is the mx plus b equation for this line right here. Okay, so what's the slope then? Well, the slope is 5/4, and the y-intercept is what? 0, negative 1. Again, b is negative 1. All right, that's the y-coordinate of the y-intercept. Okay. All right, so let's go ahead and make the graph then. So let me go and sketch my graph here. So here's y, so here's x. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so the slope is this time, they're both positive, so no big deal there. That's going to be 5 to the what? 5 up, I should say. Sorry about that. The rise is 5, so 5 up. The run is 4. That means what? 4 right. Okay, so again, vertical change is positive 5, go 5 up. Horizontal change is 4, positive 4, go 4 right. But where do I start? Well, start off at the y-intercept, 0, negative 1. So there it is. Start right here. 0 here, 0, negative 1. So where do I go from here? 5 up, 4 to the right. So 1, 2, 3, 4, 5, and then what? 4 to the right. 1, 2, 3, 4. Right there. And again. 1, 2, 3, 4, 5. 5 up, 4 to the right. 1, 2, 3, 4. Okay. So again, I get the sketch of my line here. Oops. Okay, so again, use a ruler to help you draw a straight line. Okay, so you get the straight line here. So you get the idea. All right. So again, use the slope-intercept concept. We start up at the y-intercept, and then we follow the slope from there to get the other point. All right. Again, up to this point, you can always use a table to graph, right? Because if you don't like this technique. But here's a problem where you cannot use a table. Consider this problem. Let me clear off the screen here. Suppose I want you to graph the line with slope equal to negative 3/4, negative 3 over 4, and contains this point. Contains the point. Let's say the point is let's make it negative 2, negative 2, positive 2, for example. All right. So I have a line that goes through this point, negative 2, 2, and it has this slope. All right. So how do I go about graphing it? Look, I didn't give you the equation this time, so no equation is given. All right. So how do I go about graphing such a line? All right, so let's look at that. 2, 4, 2, 3, 4. Okay. Well, if you remember, if I use the slope-intercept idea, I start at what? I start the y-intercept. But in this case, I don't know what the y-intercept is. Negative 2, 2 is not the y-intercept. And why is it not? Because negative 2, 2, here's negative 2, 2 up right here. This point here is not on the y-axis. So it cannot be the y-intercept. But fortunately, we can adjust the guidelines a little bit. If we know any point, now because for the mx plus b, y equals mx plus b form, but it's easy to pick out the y-intercept in this equation. That's why we always start off at the y-intercept. But if we're not given the equation, the reality is we can start at any point that we want, as long as that point is on the line. In this case, we are being told that. It says the line contains the point, negative 2, 2. So therefore, since we're being told this point, negative 2, 2, is on the line, then that can be my starting point. All right, so again, so technically we can start any point we want, but it's just more convenient to start at the y-intercept since we have that handy if we're given this equation. All right, make sure we understand that. So let's start off at negative 2, 2 then. All right, so negative 2, 2 I mentioned right up here. Okay, that's my starting point now. So we adjust the guidelines a little bit, all right? The graphing guidelines. All right, now, how do I find the next point? Well, I have the slope now, negative 3, 4. So m equals negative 3 over 4. So the rise is negative 3, the vertical change, so we go 3 down, and the run is positive 4, we go 4 to the right, the horizontal change. All right, so let's go 3 down, 4 to the right from the starting point. All right, 1, 2, 3, 3 down, 4 to the right. 1, 2, 3, 4, right over here. Okay, can we see that? So therefore, our sketch of a line looks like this. Okay, so sorry again, hard to draw a straight line on the sketch pad here, so I apologize. All right, but as you can see, then this is the sketch of our line right here, this diagonal line, and this is the line that will have this slope and go through this point. So again, no equation is given to us, so we don't know what the equation is. But we can graph it if I know the slope-intercept idea. All right? Now, let's go ahead and give you some problems to post in Blackboard here. Okay, so let me go clear out the screen here. Okay, post the following solutions in the discussion area in Blackboard. Okay, so find the slope. Find the slope of the line going through these 2 points. All right. So let's say the 2 points are negative 4, comma negative 2. All right. And the other point is, let's say 6, comma negative 8. All right. Find the slope of the line going through those 2 points. Okay. Number 2, I want you to write this equation. Actually, I want you to determine the slope and y-intercept. Okay, so determine the slope and the y-intercept of the following line. 3x plus 4y equal to 12. All right, determine the slope and the y-intercept of this line. Okay, so give me both pieces of information. And number 3, let's go ahead and find, let me give you this table here. All right, let's say the table here is 0, 3, 6 here, and let's say here it's 4, let's make it 9, let's make it 14 here. Okay, so given this table, this table represents some line here, I want you to find the slope. Find slope. Okay, find out how slanted that line is. All right, so post the answers to these 3 questions in the discussion area in Blackboard. All right, so until next time.